Okay, so I'm going to go over the review with you if you did the radicals review part 1 and 2. So if you're going to take the 4th root of 16c to the 4th, go ahead and break it up. So I did the 4th root of 16 and then c to the 4 over 4 because the root is going to go in the denominator. So we should know by now what the 4th root of 16 is. We should know that that's 2. And then c to the 4 over 4 is just c to the first power. So our answer is just 2c. All right, going over here to the cube root of 81. All right, and I wrote all of the exponents out in exponential form. So the cube root of 81 is 3. And x to the third over the third is going to just be x. And then how many times does 3 go into 6 evenly? It goes in twice. And there's none left over. So that's our answer there. All right, let's scroll down and look at the next part of problems. All right, so here you've got a square root of 20 and x to the third. This gets a little more complicated. So we're going to go and take the square root of 20, and then we're going to write x to the 3 over 2. So we've got to go find a perfect square that goes into 20. And I think it's going to be a 4. So we're going to factor out 4 and 5. And so this becomes a 2 with a square root of 5. Those are done. And then we've got to deal with this. So how many times does 2 go into 3 evenly? It goes in once, and then there's 1 left over, and it stays under the radical. All right, let's go and try the next one. Cube root of 32. So we're going to write the cube root of 32. Sorry about that. Somebody knocked on my door. Okay, so we're at the cube root of 32. And then, okay, so now we're going to take a and write it with a 5th power, but we're going to take the cube root of that. Okay, so now we're going to find the cube root of 32. You got to find a cube that goes into 32. So remember, you got 1, you got 8, 27. Looks like 8 is going to go into 32. So let's break this out, and we've got the cube root of 8 times the cube root of 4, and then really, if you want to look at it this way, this is the cube root of a cubed, right? And then you're going to have 2 left over because 3 plus 2 is 5. You could look at it like that. So let's just evaluate each part. You know you're going to have a cube root in here. So you're going to take the cube root of 8 is 2. Done with that. Cube root of 4 still needs to stay under the radical. And then the cube root of a cubed, remember the cube root and the a cubed cancel each other out, so it's just a. And then a squared, you don't have enough to take out for a cube root, so you got to keep all of them inside. Okay? It's the same idea of how many times does 3 go into 5 evenly? It goes in once, and there's 2 left over. Okay, well that's your answer, by the way. All right, let's go on and look at the rest of this. All right, you want to go and add up your like terms. Now, I kind of already did it, but I'm going to go back and do it again, just so you can see. All right, anything under the radical is considered a like term. Okay, so you got 3 of these, and you're going to take away 4 of them. So you got 3 minus 4. Those are basically the same as a square. You know, you could distribute that like that, right? So 3 minus 4 is negative 1, square root of 6. There's your answer. The next one's not so easy. All right, you got negative 2 square root of 3, but 3 square root of 27. I'm so sorry. Everyone keeps getting in on the announcements and coming to my door. Anyway, so I just copied that over. Negative 2 square root of 3 plus 3. Now, the square root of 27 needs to be rewritten. You need to find a perfect square that goes into 27. I think it's 9. So 9 and 3. Okay, that makes 27. Now let's go and simplify this. You got negative 2 square root of 3 has to stay the same. And then we've got plus 3 times, now this is 3, right? Square root of 9 is 3. Square root of 3. I'm really writing a lot. All right, so negative 2 square root of 3, nothing can happen. This is now going to become 9 square root of 3. Now I've got like terms because they're both the same under the radical. So it's basically negative 2 plus 9, all right, which is going to give me 7. And then both of them are the square root of 3. So you can combine them like that when you're adding. All right, look on down here to the next one. Write each expression in exponential form. All right, the 5 goes on top and the 4 goes on the bottom. And that's about it. That's all you do. So it's 2 to the 5/4. Same thing with this one, but you got to multiply the exponents. So I rewrote this as 4 over 1 because the exponent is just straight up 4. So I'm going to write it as 4 over 1 times 3 over 2. You only multiply the numerator, so it comes out to be 12 over 2. And that comes out to be n to the 6th power. All right, let's go on and try solving some equations. All right, here we go. This is a square root. So we're going to undo the square by squaring both sides. So 3 squared is 9. And b minus 1 is just b minus 1 because these two guys cancel out. All right, and then we add 1 to both sides, and we get 10 is equal to b. That's in the simplest kind of form you could do. Same thing with the other one, okay? This is a square root for everything, so we're just going to square the whole thing. All right, and that becomes 4 is equal to x over 2. Once you multiply both sides by 2, you're going to get these to cancel out, and you're going to get x is equal to 8, or 8 is equal to x. All right, let's go on down to the next two. All right, so this basically means the square root of 6b is equal to the square root of 8 minus 2b. Remember, because anything to a 1/2 exponent is going to be a square root. Now you have your square roots isolated, so let's square both sides. And we're left with 6b equals 8 minus 2b. Let's go combine our like terms, so we'll add 2b. This is going to turn out very nice and even. We have 8b is equal to 8, so that pretty much means b is equal to 1. You're writing this on in an electronic thing, like on the Power School. If you want to find the value of b, just type in 1. Don't type in b equals 1. It'll get marked wrong. All right, let's do the last one. It's a little harder. This one is not on your test, but it's good to know. All right, the exponent is 3 over 2. So we want to find the reciprocal exponent. Well, the reciprocal exponent is going to be 2 over 3. And that's going to make those exponents cancel out. Okay? Okay, so once you do that, these exponents and everything are going to cancel out, and you're left with n minus 27.
Attention, please, members of the safety committee, our meeting has begun, and you've made all the...
Sorry about that again. Anyway, so those go away, and now we're just going to do 64 and raise it to the 2/3 power. Basically, you're taking the cube root of 64, and then you're going to square it. So the cube root of 64 is 4. And then you're going to square your 4 and you get 16. All right, so let's go and erase this, and then let's go solve this equation. So once we go and add in 27 to both sides, we should get n is equal to, what, 43? I think that's what it is, 43. I could be wrong. I hope I'm not. All right, let's look at one more kind of problem that you have. Finding the domain. All right, so I've already graphed all of these, so we're going to just go and list the domain. All right, so for the f of x equals the square root of x, the domain, okay, starts at 0, 0. Okay, so at 0, 0 is where our x's and our y's start. So our domain is equal to, and you can write it as 0 is less than or equal to x, and that's less than infinity. If you wanted to do the range, it's exactly the same thing. All right, let's go look over here at h of x equals 2 over x. All right, if you notice, the graph goes along from the left, and then it drops off right at 0. And then it comes along down through 0, and then it drops off. So the only x value it is not touching is 0. So it's going to be, your domain is going to be all reals except 0. Okay, and you could write it like that. You could get it a little bit more complicated if you wanted to, but that gets the idea across. If you're looking at your table, when you get to where x is 0, you should have an error message. Okay, that's what x is not allowed to be. All right, let's go on to the next one. This one turned into a straight line. All right, so your domain goes from negative infinity to positive infinity. And I think it would do the same thing for the range if you wanted to see what that was going to be doing. All right, you can check your table. I don't think there's anything that it's not allowed to be. All right, how about the next one? The only number that it does not allow to be when you're looking at your table is probably 3. Okay, and the reason it's not allowed to be 3 is because if you put a 3 in for x, you're going to get 0 in the denominator. You can't have that. So basically your domain, oh, I don't want to do that. Your domain, let's say all reals except 3. Okay? We'll get a little more technical about that when you get a math analysis. All right, the next part of this review, you do not need to do. So if you are adding those functions together and doing all that, don't worry about that. And finding the inverses, that's not on the test. All right, so I will see you tomorrow. Have a great day and study hard for your test.